Hello, and welcome to Overlooked Artifacts Enhancing Windows Forensic Analysis. My name is Fernando Tomlinson, and I'll be going through this topic today. A little bit about myself. I'm with the United States Army. I've been in the Army for 20 years now, where I'm a cybersecurity professional focused on defensive and offensive tactics and techniques. I'm a adjunct cybersecurity professor where I teach cybersecurity related topics as well as programming topics as well. I'm a developer of various blue and red team tools, and where I can pry it out of the government's hand, if you will, I like to post those on my GitHub so I can share them with the community. There's a number of other educational cybersecurity related platforms that I'm the author of or co-author, and I'll talk about those a little bit later near the end of our presentation. But if you're looking to connect with me, it's my presence on the internet, if you will. All right, so enough about me. Let's get into really why you're here. And this really sets the stage for that calling, if you will. Okay, so we're going to go through a number of aspects, really looking at an artifact that, while it exists, in my opinion, is certainly overlooked and not talked about enough. Okay, so that brings us to this picture of this dog, and you may be asking, okay, well, what's this about, right? Well, it's really setting the stage for when someone or something is doing wrong. And in this case, we have a dog trying to take some cookies off the counter. They're fresh out the oven, and the aroma is, it's such where the dog is willing to risk it all. The dog at the core may realize, and certainly I'll say does realize, that he or she should not be grabbing those cookies, right? But instead, they decide to do so anyway. And this is largely because the dog may feel like he or she can get away with it. We can go deeper if we want to talk about the way a dog thinks and everything else. But work with me here. Now, the same could be said for malicious actors. These actors are consistently trying to gain access to a network on a daily basis, every second of the day. And when they gain said access, they're looking to set a foothold for follow-on actions. Do they know what they're doing is wrong? Absolutely. Do they care? Absolutely not. So they're looking at the prize as opposed to what's going to happen should they get caught, which brings us to the next part, right? Inevitably, when a malicious actor is doing anything on a system, much like you or I, who has an innocent tone and working on a computer, there's artifacts that are being left, that are being developed on a machine. And where a malicious cyber actor can see them, they may seek to wipe or clean up those artifacts. Now, in some cases, they may not wipe or clean up those artifacts, and for them, it's like, who cares? But when they do, it makes it a little bit difficult for us, the defender, to be able to illuminate and highlight such activity, and then what steps did they actually take. Now, I bring that point up as we talk about this picture because in my fictitious world, the dog would have snatched the whole plate of cookies, and the cookies in the plate would have smashed on the floor. The dog would be trying to clean up, right? And inevitably, no matter how well he or she thinks they did, they're going to leave, crumbs on the floor. There might be parts of the plate, although broken, up under the cupboard, or when the plate splattered, it went to a different part of the kitchen that one may not think to clean up around or with afterwards. But nonetheless, they have cleaned up and they feel pretty good about it, or they feel whatever is left, their owner is not going to be able to see. That brings us to, again, the malicious cyber actors, right? No matter what they clean up, there's always an artifact that we can find unless we just straight up destroy the machine. The real thing is, us as cybersecurity professionals, we need to be illuminated or made known that an event or incident took place for us to then want to go deeper to do such analysis. When we get to that point of analysis, well, what is it that we're talking about? We're talking about actually doing forensics, right? And in this forensics, when you look at a number of organizations or entities in this space, they all define forensics differently when I look at words on a screen, but largely when I look at the meaning or the output of how they define forensics, they're all saying the same, right? And when we think of forensics, we're essentially thinking of how are we going to collect, do analysis, and present our findings in such a way that paints a story or a sequence of events. And that brings us to, well, the forensics process. And when we think about the forensics process, well, there's a number of them out there, but I like to look to something objective. In this case, we'll use the National Institute of Standard and Technology, NIST, namely 800-86. And NIST breaks it down into four categories: collection, examination, analysis, and reporting. Well, from the collection standpoint, we're going to look to identify any potential source of data and acquire data from these data sources. This method is going to be done in such a way that is forensically sound. So if we're called upon to defend our analysis, then we can certainly ensure that there's no holes in what we did for somebody to call us out on it. That then brings us to the examination aspect. Well, this is where we look to not only assess, but also extract the relevant pieces of information from our collected data. This data may involve by us, or the data that we do analysis on may involve us trying to bypass and mitigate operating system or application features that obscure data or code from us, right? We don't want that. Such things like data compression, encryption, or access control mechanisms. From an analysis standpoint, well, this is where, and really at the point that we've already extracted that relevant data. And this is where we are actually doing our true analysis. Go figure, the analysis stage contains the analysis, right? And this is where we're studying, we're analyzing the data to draw conclusions from it, right? And we want to make sure we're doing this in a methodical way so we reach an appropriate conclusion without skipping over information. This analysis should help to identify the relevant aspects of what we're charged with doing and what we're charged with either answering, right? So our analysis should seek to answer specific questions. Often we'll be able to correlate data amongst multiple sources that we would have collected. Finally, that brings us to the reporting aspect. And this is where we get to not only report, if you will, but this is where we get to present our findings of our analysis. We're going to present this in such a way where it's easily digestible for the techies, but also speaks in terms that leadership can understand. Now, with all that being said, we're not going to focus on all of them for the purpose of this talk. We're only going to focus on those three: collection, examination, and analysis. And the artifact that I'm speaking of is going to span all three. So let's really paint the situation here, right? We find ourselves in a suspected intrusion has occurred. The customer, when we're called upon, lacks the event, firewall, application logs, heck, any logs at large. The IDS isn't working, and packet captures. What's a packet capture? Now, from that perspective, what have the malicious actors done? Well, they've not only removed their malware, but they've cleaned or wiped any tracks that they are aware of that would be indicative of something or someone being there. Now, where does that leave us? Well, that leaves us with the only clues that we have are whatever's not stomped on by the customer. Because as you know, when things are deleted, they're not actually deleted from disk right out the gate. The pointer associated with where that data is at is on disk is actually removed. So as things are continuously being done on the disk, that information could be overwritten, right? So this is where time is of essence. Now, we understand at that point, we feel like, okay, well, this is going to be a long day, week, what have you, and our mood, well, not so good, okay? But as true professionals, cybersecurity professionals, we are constantly thinking about how can we disprove, or do something outside the box. And as we understand what our goal is, we find other ways to achieve it. And this brings us to the actual artifact itself that we're going to talk about. And this is the System Resource Utilization Monitor. And you may be asking, well, what's this System Resource Utilization Monitor that I'll refer to as SRUM from this point forward? Well, essentially, it is an artifact first seen in Windows 8. Yogesh Katar actually is the one who first found it, brought it to light. So we thank him for that. His analysis, his research has really set the stage for a lot of this. The actual SHRM service or database rather is part of the diagnostic policy service. So if we want to stop writing to the database, we can actually affect the service, which then precludes the writing to actually take place. Now, this whole thing collects statistics on network connections, Windows application services, and applications as a whole. This is great because when we think about an actor being on a system, we understand that on disk, binaries are going to be executed, processes are going to be created and terminated at some point. We also recognize that an actor is generally, or may not, in some cases, most cases, be interactively on the system. So they're going to have to traverse some form of network connection. And this is where the SHRM database actually helps us as well. Now, this whole thing is going to be stored in an extensible storage engine sitting in a System 32. And historically speaking, we can go back roughly 30 to 60 days. Within this database, there's a number of tables, and the tables with how much data they contain certainly varies. Okay, so on our system, we're going to be in system root, and we'll see within System 32 SRU, we'll see the SHRM database listed as srudb.dat. Now, looking at the screenshot, we see a number of other items there as well. Those are transaction logs that are associated with the database. If we want to get a copy of it, well, on a live system, we're not going to be able to because the system is, or that database is actually locked by the operating system. Think of it kind of like registry hives, right? On disk, they sit in System 32 config. However, when that system boots, those hives on disk get loaded into memory. Same kind of principle here. All right, so when we're looking at it from a GUI perspective, well, when we're in Task Manager and we go to the App History tab, we're seeing information that is being fed from the SHRM database. Okay, we're showing the statistics on applications. This does it for apps in desktop applications, but by default, we only see the apps. If we want to change that, we'll be able to go Option Show History for all processes. What can we do with this? Well, we not only see the binary that's executing, we see how much time it's had as far as processing time. We see the network traffic associated with it as a whole. And we see where the binary is on disk, not from this view. However, if we were to right click any of them and select properties, we would be able to see that. Now, in a case where you see uninstalled processes, well, that just insinuates that the process itself, or excuse me, the binary itself no longer exists in the place in which it executed, or it may not exist on disk, right? So that's just what it tells us. Now, moving from that perspective, well, we start to look at how the data is collected. And while there's DLLs associated with the service, the DLLs, when they catch and write this data, it's gonna be stored in the registry, and it gets written to the actual database once every hour or on system shutdown. Once every hour or upon system shutdown. Now, from that perspective, well, where in the registry is going to be stored? Well, we see that location there as well, and we can navigate out there and see that information. All right, so this little chart helps to tie together a couple of things. When we go look at that registry location that was on the previous slide, we'll see the SHRM extension, and under there, we'll see keys. These keys will be named what we see there, the app timeline provider, Windows network data usage, all that good stuff. And for each one, we'll have a DLL that is associated with it that is being loaded and doing the capturing for each one of those extensions. When we look at the database doesn't have these extensions in a nomenclature that we understand. Instead, it has the GUI. So I took the GUI listed in the database and married it up with the extension listed in the registry. And in the last column all the way to the right, I tried to put a nomenclature that was easily digestible, readable, understood by most. Now, you'll see some that are unknown, and this is largely because I don't know. And documentation about this database and how it really works is scarce. So it's a continuous thing to understand and learn more about it. The other big thing I want to highlight here is the last one, the SRUDB ID map table. Well, there's certain data in these tables that are essentially blobs of data, not human readable. And within the ID map table, you can think of it as a lookup table. Okay, so the lookup table is going to have a subset of information that we'll then be able to make sense of and then translate it and replace the blob with that normal data. We're going to have to do that ourselves, and I'll talk about a couple of ways that we can do that. But for the purpose of this talk, these are the five tables, tables that we're going to focus on, right? 4 of them are focused on data that we can glean, and then the 5th one is kind of that lookup table that we need to be able to make sense of some of that documentation or some of that data that we find in the database. All right, so that ID map table, again, we're going to find a blob, and that map table contains 3 columns, so 3 properties: an ID type, ID index, and ID blob. I'll focus on the ID type. If the type is going to be 1, well, that insinuates that the data that's in the blob column is an actual base64 encoded string. So we can make sense of it by decoding it, right? And that's going to be the same thing if it's 0, 1, or 2. Now, if it's value of 3 for ID type, then the blob on that same row is going to be a SID, and we'll be able to reverse that process to illuminate that SID. But this is where the ID map table is hugely important, or else we're just going to have data that we can't do anything with. Okay, so to get after this, developed a PowerShell script to really make sense of this information for me. So highlighted or circled in orange, this is where I'm checking to see if the data equals 3. And if so, I'm going to start my conversion process to bring it back to an actual SID, right? And you'll see in red, this is where I'm converting the blob, where it was 3, from hex to bytes. And then in green, then I'm actually converting the bytes to the raw SID. Now, I've said before that if it's 0, 1, or 2, then it's going to be a base64 encoded string, if you will. And all we got to do is decode that. So if it's not a 3 for ID type, well, it's going to be 0, 1, or 2. And then in the blue, this is where I'm just decoding that base64 encoded string. All right. Now, looking at those 4 tables, one of them is network connectivity. And this is where we start to dive into, what does that do for me? Well, some of the available information in there is the application that was executed, the user ID, network interface type, wireless profile. Holy crap. Yeah, if it was hooked up to wireless, we can get the SSID and it will be in there as well. Now we'll have to use the software Hive from the registry to be able to translate that, but yes, we can get it. We can get the connection time and the total connected time for that connection. Forensically speaking, I now have the time frame associated with an application. I won't be able to get the true time, but I have a time frame. I'll be able to get the user who executed it, a potential location of the device, specifically if I know where specific SSIDs are, right? I'm in an organization and we, for some reason, have wireless in our organization, and each floor has its own SSID, or it says Starbucks or something like that off of, a particular area. All right, that just kind of helps us. Or we might be able to look to something like Wiggle to be able to help pinpoint that. The connection duration, was it short? Was it a short burst? What was it? And are these connections unusual or not? Is this indicative of something that other people in our organization uses, or is this a one-off? Is this something indicative that this user that persona or this workstation uses, or is that a one-off? That brings us to network data usage. From a GUI perspective, again in Task Manager, we'd be able to look at this from performance. The big difference here is this doesn't have connection start time or the total connect time, but it starts to give us a lot of the same data from the previous one. A big difference here is we get the bytes sent and the bytes received. Holy cow. So I may have a process, we'll call it nando.exe, and I'm thinking that that is malware, no longer exists on disk. And when I look at the bytes sent and bytes received, I'm seeing a substantial amount of bytes being sent out. That could be indicative of exfil, right? That's a game changer for us. We get things like the timeline or the time frame the application executed, just like the other one. We get potential of indication of the exfil, like I just talked about. That's a big game changer. We also get the location or being able to kind of figure out if it's unusual in perspective. But looking at both of those, this is data that's already being collected and it's on by default. Whoa. All right, so that brings us to application resource usage. This starts to get to the application. So we see application, user SID, how much it's in the foreground or background for cycle time, network bytes, read and write, context switches. That helps us with the time frame of the application, the user that executed it, right? At least the SID, and then we'll be able to take that and translate it. We can do that in the registry if it's local, or we can do that within AD if we need to go within the domain. And we start to highlight again potential exfil of data based upon how much data is being written or being sent in and out. Now, this also corresponds to Task Manager within App History as well. And then lastly, we have the application timeline. This is going to focus on a lot of stuff that the previous one for application resource usage focused on, but we also get duration in the span. We also get the total bytes associated with the connection, right? However, it's not broken down by read and write like the other one. This may be able to help us find things like, I don't know, crypto miners actually executing on our system. And like the other one, we'll find this in application history, right? So we see a hodgepodge of that information shown there for us. So that we start to see this, well, what are the tools that we can use to parse this data? Well, you have an in-script parser that Yogesh, the person who did the initial research and found majority of this, created, and he's got links out there. However, the links are dead, and if you want to get that in-script parser, you need to go back to the Wayback Machine and to be able to retrieve it. If we're using an in-script parser, you guessed it, we need to be using in-case. This is going to work off an offline system offline analysis. Now, we also have Velociraptor's ESC parser. This is a endpoint cybersecurity solution, open source, free in nature. That's going to allow us to do online analysis of this database. Now, this is going to require that you're using the endpoint cybersecurity solution. So if your organization is not using it, well, I wouldn't say go get this just for that. But if you are using it, it's your lucky day. You also have ShrumDump, which requires an external binary. It works off of live and offline databases. So that's good. But if you're in an organization that you have to jump through all kinds of hoops to be able to use binaries that aren't approved, or there's some type of accreditation process, that may not work for your organization. We also have ShrumE command. That's going to require an external binary as well, and it works for offline analysis. We have ESC database viewer, and that's going to be a portable executable requiring yet another external binary, and it's going to be offline in nature. Now, the 5 that I've talked about thus far, they're great tools and they do exactly what's needed. Your environment will dictate which of the 5, if any, you'll use. Which brings me to my last one, Invoke ShrumDump. Now, Invoke ShrumDump is something that I created, and it works on pure PowerShell. I say pure, there's some .NET in the background, but really what I'm trying to highlight is you don't need anything additional aside from a Windows machine where the Shrum database would actually be, because that's going to be Windows specific. This allows us to dump the contents of this to Excel sheets or workbooks, so that way we can do our analysis from that. We can do it off a live or an offline machine. If we're doing it off a live machine, we're going to need admin rights. That's no different than the other tools that I talked about. They also need admin rights if we're doing it off a live machine. This is going to help us normalize and translate fields within the database with other tables, specifically that ID map table that I talked about. Where I can, I certainly translate that. And guess what? If you feed it the software Hive, it will also pull up that SSID I mentioned and put that in your output, making this a one-stop shop for you to be able to really do your analysis. Sorry, got ahead of myself here. All right, so with that, that brings us to our data translation interpretation, right? These timestamps are going to be in UTC. UTC, we're talking 64-bit file time, only format, and that's one of the things that we're going to have to translate. So here's a couple of lines of code where we can translate that using PowerShell, and that's what's being done in our code there. The network interfaces aspect, well, that's going to be in such a format that we'll need to translate as well. There's some bit shifting, some anding that we'll have to do to make that useful. And then guess what? The SIDS, I talked about that. I also have to translate that as well. So those are the big things that have to be translated, interpreted within the database for us to be able to make sense of it. Now, if we want to copy the database, well, we have a couple of options. If we're doing offline analysis, we don't need any special tools. We mount it using whatever our forensics tool set of choices that gives us access to that disk. If we're talking about online and we want to copy it, well, we could use something like FTK Imager. We can do volume shadow copies to get it. We can download hobo copy to our machine. We can use robocopy, or you can do the method that I did where I utilize PowerShell. Now, when you're running invoke Shrum dump, it's going to not only, regardless if you're doing live or offline, but for the purpose of this, I'll say I did live, it's going to copy that Shrum database and create a folder on the user's desktop called Shrum and the date. That's fully customizable. You can have it point to a different directory if you want to, but if you don't feed it a directory by default, that's where it goes, and it copies it there. And then as it parses the data in the database, these Excel documents are then stored in that same directory. So as I go through this, well, what does that look like for us? I have an example here where that data is parsed, and I have a time frame associated with my analysis, and specifically I'm looking for 1 September. 1 September, I see netcat being executed, as we see covered in red there, and then the next column we see the SID. Okay, again, we don't have the actual user. We can get that information, but now we have the SID that previously was a blob of data. It's translated into something that we can read from a human perspective, and we can look within the registry or in AD to understand what user that is. We see a couple of other things such as the duration, the span, so that's great. But right after that, I start to see stuff like who am I, task list, command, ipconfig, netsh, art, reg. Now, I'm not saying all of these commands are malicious, right? They have a legitimate use. They're part of the operating system, but it almost seems like netcat happened. I want to see what type of, how much data was sent and received. I'll get to that in a second. And then we see a series of commands that could be indicative of an actual survey taking place on the machine. Okay, that's interesting. That brings us to actual network connectivity. And when I look at network connectivity, in this instance, I was unable to get the actual application in the user SID, but because I have the time frame associated with it, well, I can look in that perspective. And I see that the machine was connected to a SSID called FBI surveillance. Now, I think somebody's trolling me here, but nonetheless, I have the actual SSID. Also, in the next column after that, I see the connected time, how long it's been connected, and I see the connected start time. Okay, well, that's super helpful because then I get to a point where I look at the actual network data and I see Netcat actually was sending bytes over the wire. I then see the SID associated with it again, that time frame. This is being written once an hour again. I see that it was off of the FBI surveillance. And although I've cut some of the properties off, the columns, I at least captured the bytes sent and the bytes received. So not a whole lot sent, not necessarily a whole lot received, but certainly it did communicate over the wire, and I am concerned with that. So now I've taken essentially data that didn't really prove anything to me. I didn't even have a good place to do analysis, and I at least have this. This is immutable at the moment, so an attacker stepping on this is not going to be so easy. But given this, and really what we can glean from it at large, you may be thinking, well, this is the answer to all my problems. And I'm here to tell you, yes, but no, it's not. Right. And I recall being on a ransomware case where we caught it left of the boom, if you will, where the attacker gained access. They moved laterally all over the network, brute forcing their way around, and they laid down so many, or not so many, a number of implants, right? And the AV product that was in this network, it was capturing when their implant was beaconing out and bringing down a different stage and writing it to disk. That AV product was misconfigured. So although it was captured and taken off of this, we didn't have artifacts in the AV product to see what it is. And I didn't know that what was going on at the time. However, when I looked in the Strum database, I was able to see, holy crap, this guy downloaded 1 million of these things, right? And then we were able to then dig a little bit deeper to understand the AV product had actually done its job, and it was poorly configured, so that way we couldn't actually see it. However, we seen everything that touched disk, and this guy was just trying his poor heart out. Now, I don't know if we would have seen it elsewhere because of our position and when we had got called in to this incident. All right, so if you think this is the holy grail, if you will, and I'm telling you it's certainly nice, but not everything. Well, what's the bad part? Here's some limitations and concerns. The database stores up to 30 to 60 days. This isn't going to get you years back, right? If you think about something like SolarWinds, well, 30 to 60 days didn't do you good, right? Because we're talking a large scale of months, right? The data is written to the database every 60 minutes or when the system is shut down. So that's a limitation, and documentation is certainly scarce, right? You have some research by a couple of individuals that are out there, but largely you're not going to find a whole lot about it. All right. So if you're on the other side of the fence and you're like, well, hey, how do I circumvent this? Well, I like to use the pyramid of pain from an opposite perspective and kind of point it like this. Well, we've already said that there's a service associated with this. So if we disable the service, that's going to be certainly easy right out the gate for us to mitigate this. And then going up the pyramid here, we can delete the stage data in the registry. Now, we might have an EDR that's going to illuminate that. And to be able to delete within a registry, we need to have a certain level of rights. Same thing about stopping that service. So our access and really what we have available to us may vary and shape what we're going to be able to do. We could terminate the threads associated with this service that's running in the context of a process, right? That allows us to still have the process and everything running with the service, but the actual threads or handles within it would be terminated. And those were the ones that are really doing the work. So now we start to evade any EDR that may be running in this organization. And then lastly, if we're lucky enough and position ourselves in such a space, we can operate solely in memory, which kind of precludes this from being a thing at all. All right, so where does that leave me now? That leaves me to future work. Well, what is it that I want to do? I really want to get after parsing the rest of the tables and turning those unknowns to knowns. I want to add a SID lookup capability in there. So I'm not just providing you the SID, instead I'm providing you the actual user as well. And there's so many other tables and information that can be gleaned. I want to be able to translate other aspects of the database to make this a thing that you look to first, as opposed to a thing that you think of when nothing else is available. All right, so that brings me kind of to the end. However, you may have noticed that I used some PowerShell magic to get after this. And as you know, PowerShell is built into all Windows machines and is now cross-platform and available on Mac and Linux. So this is a good time for you to learn PowerShell because you were able to see kind of what I was able to do with it. All right, and a couple of ways that you can do that. Well, you can look to a site that me and some friends put together called Under the Wire. It was first developed in 2015. We have 75 interactive challenges. They're linear in nature, so you're going to do one after the other. To date, over 190,000 unique people have played Under the Wire from 78 countries. This platform really focuses on the core aspects of learning the language. And when you think you've honed your skills there, well, then I challenge you to do Posh Hunter. Posh Hunter is something I developed back in 2017. This contains 90 challenges, all interactive as well, defense and offensive focus, again, blue and red team focus, and they're non-linear so you can jump around. I'm going to give you a virtual machine and some tasks. You'll complete those tasks. You'll then submit those answers and you'll get points. This gives you the perspective, or really puts you in the perspective of somebody who's utilizing PowerShell offensively or somebody who's going to utilize PowerShell defensively. At any rate, you're going to walk away a better positioned individual. With all that being said, that brings me to the end. Now, if you're interested in a copy of this presentation, it'll be hanging out there on my website as you see before you. If you want to get a hold of Invoke Shrum Dump, well, luckily the government didn't tie his hand on that, so I have that out there on my GitHub where you can go and download it and use it to your heart's content. If you want to connect because maybe you and I speak the same language, well, let's do that. Let's do that on Twitter, and you see my handle there. And with that, I appreciate everything the BSides Charlotte folks have done to put this on this year. This isn't my first year, certainly won't be my last. This is such a great conference, and I hope you're enjoying yourself. Thank you.